All right. Hello, everybody. I know you guys were absent yesterday, and I have a sub today, so I am going to give you the presentation or the lesson of what we did yesterday in class, because today's class activity you cannot do without yesterday's activity. All right. So in our calculators yesterday, we were playing with triangles, and we were changing our length and our sizes. This line here, line TI, we were changing the angle so that we could create triangles. And sometimes we found out yesterday that sometimes with our length here, this TI side, sometimes we will have one triangle like this, or we can create a different type of triangle like this. And notice I did not change my side length at all. I did not change that at all. The only thing I changed was the actual angle measurement of this angle I. Okay? And so yesterday we were playing with triangles, and we changed this up so that sometimes we created triangles with this acute angle right here. Sometimes we created triangles with the obtuse angle all the way to this line here. And sometimes we created triangles with the 90-degree triangle with this line here. Okay? And they all kind of had the same basic properties. So with this T for line, this TI line, if my angle, if TI, this is TI, was shorter than IN, there were a couple different possibilities. So if it's shorter than IN, then sometimes I can make one triangle like this one, or another triangle like this one. So sometimes I can have two possible triangles. Sometimes if my side length here is too small, let me shorten this. So I've shortened that length. If it's too small, it doesn't matter what my angle is. There's no way I can reach this line here, which is for the acute line. And so sometimes I can cause two triangles to appear with this acute line, this one and this one. But if it's too small, I can't have any triangles. Okay? And then with my acute triangles, if I have it super long, if this side is super long, so let me show you. So right now, TI is longer than IN. So if it's super long, then I can have a triangle, even if this angle N is obtuse, I can have a triangle. If it's a right triangle, I can still have a triangle, but just one. Notice that this is just one option. I can't create two different triangles here. I can just create that one. And if it's an acute angle, if N is acute, I can still make a triangle, just one triangle, when TI is greater than IN. Okay? Now let me see if I can set it up so that TI and IN are the same length. About right there, almost. I don't know what's going on. All right, so here's our TI. It's a little bit too long still. Let me see. Oh my gosh, it's crazy. It's really hard to do this. In fact, yesterday in class, the kids just observed me doing this. All right, so now there's approximately the same length. If I try to reach the right triangle, okay, I can't do it. And it's because this length here should be the hypotenuse, which means that this length has to be the longest side. If it's the longest side, then TI has to be longer than IN. And also notice I can't reach my obtuse line here. either because this side is not long enough. Okay, so we just explored different ways of making triangles. I can, if I have an acute angle here and TI and IN are the same length, then I can still make a triangle. So that was basically all we did yesterday for the first half of class. And then we kind of set up this table to analyze what we knew and what we could find out. So one of the things is that when we have an acute, an obtuse, or a right triangle, there's one situation where we will always find one triangle. Okay? And that is when your TI is greater than IN. Okay, so here's a picture of the triangle scenarios again. If this is N here, this would be side N here, and this would be side S here. This would be side I here. Okay, whether we had an acute, a right triangle, or an obtuse triangle. Okay, for every single one of these, this is always your side I. Let's see, side I. Okay, notice I have 3 different options there. All right, so if we have this, if we know one side N here and another side S, and the non-included angle, in other words, this angle here is not in between the 2 sides that we know. If that's the situation, then what we have is a side-side angle triangle. So we know 2 sides and one of the angles that's not this one. So it cannot be in between. Okay, with that situation, if your opposite side is greater than OPPOSIT, my thing is not working. That's supposed to say opposite. So if the opposite side is greater than the adjacent side. Oh my gosh, this is messing up. ADJ, A, I'm going to leave it. That's an A. CENT. So if the opposite side is greater than the adjacent side, then you will always have one triangle. It doesn't matter if this angle N is obtuse, acute, or a right triangle. You'll always have one, only one option. Now, what happens though if if your opposite is less than your adjacent side, okay, then it's possible to not have any triangles at all. You could have 0 triangles. You could have 1 triangle, or you could possibly have 2 totally different triangles. Okay, so that's the other options that we have 2, 0, 1, or 2. So this is if the opposite is less than the adjacent. Remember, if this is our angle, this is our opposite side is N and our adjacent side is S. Okay? This is a scenario that creates ambiguous triangles right here. And it's a pain in the butt because you can't just look at the side measurements or the angle measurement and say, oh, I know that's only going to be this one triangle. Because if you look here, you've got 2 different possibilities. Okay, notice in both of these triangles, my angle is 50 in both cases, the opposite side is 10 in both cases, and the adjacent side is 12 in both cases. So this is a situation where your opposite side is less than the adjacent side. Okay, anytime you have that, there are 2 possible options. Well, actually, there's 3. You could not have a triangle at all, or you could have 1, or you could have 2. And this is a case where we have 2 different triangles. Okay, it looks super complicated to find both the measurements of both triangles, but it's really easy. Okay, we're still using our law of sines that we've learned before. And in this case, our ratio is going to be 10 divided by sine of 50. And we're setting that equal to, that's an equal sign, the ratio of side E, which is 12, divided by sine of E. Okay, and we've done this a million times, so we know that eventually we're going to cross multiply and divide, and we'll have sine E is equal to a ratio. And because we're looking for an angle instead of the ratio, we're going to do inverse sine because we want to find out what does E equal. Okay, if that's the case, then we're going to cross multiply and divide. So the ratio inside the parentheses is going to be 12 times sine of 50 and that's going to be divided by 10. Okay, when you plug that into your calculator, you find out that that is approximately, or E is approximately 66.8. Okay, so right now we know that E is 66.8 over here, and notice it's an acute angle here, so that looks like it'll fit. Notice over here though, E looks like it's obtuse, and it sounds super hard to, or it seems like there's no way we could possibly find out what this other angle is. It's actually super easy. Okay, you take 180, subtract it by our first value for E, and we're going to get that it's equal to 113.2. Okay, so now that means that the alternative angle will be 113 degrees, 113.2 degrees. Okay, so in one scenario E is 66.8, in the other scenario it's 113.2, excuse me. At this point, I'm going to solve for F. I want to know what's the measurement of angle F. For this scenario, I'm going to do 180 minus my angle of 50 degrees that I already have, my plus the measurement for angle A, or angle E, the 66.8, and that will give me the measurement for angle F. Okay, when I do the calculations, I find out that angle F is, hold on, 63.2. Okay, and then over here to find out the measurement of angle F, same kind of thing, except I'm not going to use this 66.8. I'll use 180 minus the combination of 50 plus my angle measurement here, 113.2. Okay, and that tells me that this time angle F is equal to approximately 16.8. All right. So notice that because E is different, your F is also going to be different. Let me draw one out here. That should be 16.8. There's the one. 6 and a 8. Okay, and because these two angles are different, your side F is also going to be different as well. Okay, we've used the law of sines to find our side measurements a million times. Set up your ratio again up here, the 10 over sine 50. 10 divided by sine of 50. And set it equal to your F ratios. So this time we're looking for F instead of an angle. So we will not use inverse sine here because we're looking for a side measurement. So sine of 63.2. Okay. And so that's the ratio, to find this side measurement F. Now if I wanted to find this one, I would set up everything the same here, except for this angle right here would be 16.8 instead of 63.2. Okay, so essentially, a couple things to know. If you have a possibility of having a side or having an ambiguous triangle, you have to have a side-side-side angle. Okay. The opposite side has to be less than the adjacent side. Opposite has to be less than adjacent. Okay, if that's the case, then it's possible to have an ambiguous triangle. It doesn't mean you will always have an ambiguous triangle. One of the ways to find out is you go through this process that we just did. I'm changing my F. So angle F equals 16.8. And what we did first is we found the first option for our measurement for angle E. Then we subtracted it. The minus sign is right here. We subtracted it from 180 degrees, and that gave us the alternative angle measurement for E. Okay, then you find your two F's, okay, and then you can find any other missing information. Okay, you need to know how to do this for the exercise that you're going to do today in class, and you need to know it for the test. Okay, if you have not watched the law of cosines video, go ahead and watch it tonight. You need to have it watched before you come to class tomorrow. All right, hopefully you found this helpful, and sorry I couldn't be here to answer any questions. If you have more questions, talk to me in class tomorrow. Bye.